The very first student I ever worked with was Frank Petoniak. He was a captain in the Air Force. He was at the Air Force Institute of Technology at the time I was there. I guess I was looking at this. I guess I was a lieutenant at the time, and I was directing a captain, but I had a PhD and he didn't. Then my first PhD student was another captain in the Air Force, Alten Damani. That was in 1982. But Alten was a captain in the Israeli Air Force. Israel sent him. He was active duty. They sent him to Purdue to learn about fracture mechanics. Then he went back to Israel. He retired as a brigadier general in the Israeli Air Force, and we recognized him as an OAE, I guess, in, what does it say, 2001. New materials. If you want to select structures for long service lives, you need to look at materials. And new alloys, new manufacturing methods. This comes to home. If you remember last month, Alcoa built the world's largest aluminum lithium processing plant here in town, across the river. Okay, and aluminum lithium is a relatively new alloy, although it's been in development for a long time, and we were involved with some of the first research on aluminum lithium alloy back in the 80s, late 80s. Gordon Kissler, Julian Henkener, and Andrew Blatt all did master's theses dealing with fatigue and fracture of this aluminum lithium alloy. So it's been neat to see that finally be developed and used and actually come here. Well, the last one is old structures. We've got a lot of old structures, whether they're airplanes or whether they're bridges or nuclear reactors, and we want to determine the life of them. So I'll talk a little bit about this, because this is kind of a fun one. I like this picture, these airplanes that are stacked up and being wrecked, being ready to be trashed. Now, is that an opportunity or is that a problem? Old structures. Can we continue to use old structures? Well, as I mentioned, we had back in the 90s, we had a large contract from the Air Force Office of Scientific Research, involved Professor Sun and myself and Professor Ferris from Arrow, Hilberry from ME, Quam, Eric is here someplace from MSc, and George McCabe from Statistics. I think we funded 20 graduate students over the 3 or 4 years that was in effect, 18 theses, published some 75 papers. So this was a sort of a big effort. Digress a little bit and tell you about my experience with old structures. Part of doing this research is I'm not afraid to fly in old airplanes anymore. 2 experiences. Last summer I had a chance to fly in a B-52, B-17. This is kind of exciting. Actually, one of the guys that went with us showed up with his walker, but he was a B-17 co-pilot. In World War II, he flew 22 missions over Germany. And the thing that really impressed me was he could still wear his jacket. His uniform still fit. And then some experiences with flying with my dad in the plane that he flew. Well, here, the B-17. Very small. You get in there, airplane's a lot smaller than you think it is. I took that picture from this seat in the back. That's exactly what that airplane went through. When I showed you before, the B-17 took the mid-air collision, it went right through here. So I was sitting right there. I knew if there were any German fighters in the area, all I had to do was keep my head down. But it was a good opportunity to look at the structure and see, the amazing structure on how resistant that was. The one that I really appreciated, old airplanes, was, this has been 15 years ago, had a chance to fly in the airplanes that my dad flew in the service. So this was in Connersville. They had 2 of these AT-6s, the trainers. I'm in this one, Dad's in that one. We took off together in the same runway. My wife took this picture. Her dad's taking this one of me. I'm in there right when we left off, and then he's next to me. And then I took that picture of him next to him. I told the pilots ahead of time that I wanted to reproduce this picture. This was a photograph we had around home of Dad in the war. And so I told the pilots, I said, I want to fly up next to Dad and reproduce this picture. So this is Dad in the front seat of an AT-6 54 years later. That was a neat experience. Actually, my mom was more excited about this, I think, than Dad was. She kept telling me all that day that this was my second flight in an AT-6. because evidently Dad had taken her up for a ride a couple months before I was born, when she was pregnant. So she thought that was neat. Well, I had this picture around a long time. I used to have it in my dorm, and I never knew the date. And Dad had brought along his logbook. And so he found the date of this thing. And that picture was taken 22nd of September 1944. If you remember, I said I was born the following July. Mom always said I was late. I never discussed this with either one of them, but that very well could be my first flight in an AT-6. Kind of creepy to think about this could have been the night I was conceived. Okay, well, anyway, we get back to technical stuff here. The aging structures is a very complicated issue, and it's really a neat one to talk with students about, engineering students about, because it brings in a lot of things besides just the technical problems. There are very significant technical problems, stress analyses, fatigue cracks, corrosion, all kinds of difficult technical things. But it also brings in economic issues that you can talk with engineers about. Here's a 25-year-old headline from an article in the Wall Street Journal. They were talking about some economics involved in refitting some airplanes. The Lockheed wanted to refit the C. They were going to spend $4 billion on that. Boeing said, no, you want to buy new airplanes from us, they would sell them to you for $5 billion. And McDonnell also wanted to sell new airplanes. So anyway, you could talk with students about money involved in these decisions. These technical decisions aren't just stress analyses. It's how much is it going to cost and how long is it going to take. Airplanes aren't off-the-shelf items. So that's a really neat thing that you can talk with students about. And then, of course, the other thing that comes into play here is public safety concerns, regulatory issues. It turns out that you can have the world's safest old airplane, but if the public is scared of it, you got a problem. And by and large, that's what's happened with airlines. Most airlines have got new airplanes now. I think many of public reception, public impressions. Military is continuing to fly old airplanes. We have 60-year-old B-52s and 60-year-old KC-135s and so on. Now, there is an issue here which we'll talk a little bit later about widespread fatigue damage. That's sort of a public perception issue. Okay, aging aircraft. One of my colleagues likes to compare old airplanes with old people. He says that same symptoms. More severe service usage, increase in gross weight, I can attest to that. Inadequate maintenance, inadequate protection systems, presence of widespread fatigue damage. Well, widespread damage, not necessarily fatigue damage. Parallels. In fact, another parallel, years ago went to an aging aircraft conference in Palm Springs. Took my wife with me, and first day I was at the conference, she went on a bus tour, and they told her about these fabulous Palm Spring Follies. And she said, Skip, we got to go to this. She says, they've got, it's an old vaudeville show, and they've got a bunch of ladies, old ladies, that are going to be out dancing. The youngest one is 57, and the oldest one is 87, and they're going to be out dancing. And I about told her that the last thing I wanted to do was to go see a 57-year-old lady dance. Fortunately, I kept my mouth shut because my wife was 57 at the time, so I didn't say that. But we did go to the show, and it was a really neat show. It was a wonderful thing. Now, as I went to the show and thought about it, you'll get the comparison here between the old ladies and the old airplanes. There's two things there. If you want to extend the life of a structure, whether it's a bridge, or whether it's an airplane, or whether it's your car, you need to have two things. You need to have a sound design to start with, okay, and you need to have had rigorous maintenance. Now, these ladies were obviously sound designed to start with. In their 20s, they were professional dancers. Probably most of them were probably strippers. But they were obviously sound designs, and they had obviously taken good care of themselves too. So the parallel between the body and the structure, is there. Now let's skip this one. So one of the things which we did do a lot of research was widespread fatigue damage. Now you remember I popped that balloon, okay? And I said that we built damage tolerance in the pressure vessel so that those stringers are supposed to stop a crack and you're not going to get an explosive decompression. Well, that mechanism was defeated in this incident here. This was 25 years ago. This was one of the poster childs for aging aircraft. This was the Aloha Airlines incident. And what happened was there was a series of cracks that had developed along a lap joint here. And instead of the cracks stopping at the stiffener like they were supposed to, and the pressure being leaked out like that balloon did, it didn't stop. You know, it went about 10 stringers, and they lost this huge 20-foot section of the airplane. Now, the airplane did survive that. It did fly for 20 minutes and land safely. And there was one fatality. There was a stewardess who was in the aisle at the time the explosion occurred, and she was lost, but the rest of the people, you know, were safe. Okay, so that though is an example of one of the things that problems with aging aircraft is that it can defeat our crack arrest mechanisms. The deal here was when I popped that balloon and when people did tests and showing to demonstrate you could arrest cracks, that was always a new structure. No one ever really considered what would happen if you got a big crack and he propagates, but he goes into a structure that's old and it's got little cracks. So that was a failure mode that was not anticipated, wasn't really thought about until this incident. Well, we wound up doing a lot of research on this. This is a slide I show a lot in class. A number of years ago, I was in Australia teaching a short course, and Barb was with me. And the weekend before the short course, we decided to fly down to Tasmania and just do a little bit of visiting. And at any rate, I had my notes along like a good professor. I was going to be teaching next semester, so I was looking through my notes. And I told Barb, says, you complain I never tell you about my work. And I said, well, I work in damage tolerance. This is a slide I'm going to show next week. This is an airplane with widespread fatigue damage. By the way, we happen to be on this airplane, and you're sitting in that seat right there. I purposely, it was open seating, and I purposely selected that seat so that because I wanted to be there. So I told her all you got to do is make sure your seatbelt's on, and you'll be okay. I don't think she's ever forgiven me for that. Okay, well, real quickly, I did have the opportunity to be head for a number of years. I think over the 7 years I was head, I think we averaged 23 FTE. We awarded 1,300 degrees. I think that's the most of any degrees, aero degrees in the country at the time. There were a couple schools that had more bachelor's degrees, several schools that had more graduate degrees, but when you add them all together, I think we probably produced more than anybody in the country. Very, very proud of those 23 faculty. You know, over that 7-year period, we averaged 500 undergraduates, and we averaged 140 graduate students. I'm sure that by far that was the largest student-faculty ratio in all the schools of engineering. We funded, the faculty had $2 million of funded research annually. Again, this was in the mid-'80s. We hired 12 faculty. 4 of them got PYIs. 5 of them got Best Teaching Awards from the school. One of them, Tom Ferris, became the longest-serving head of the department. He was head of the department for 11 years. At least 2 others of the faculty we hired that time became heads at other places. 5 of those people are still faculty, are still with us. History. I told you I was interested in old airplanes. Well, I'm interested in genealogy. I've been able to trace my family back, I guess 11 generations to somebody who's born in the early 1600s. Being able to trace Barbara's back 12 generations, again to somebody who's born in the early 1600s. But I'm more interested in the genealogy here of the school. And a number of years ago, I was over in the library looking through old yearbooks, 100-year-old yearbook, 1910 Purdue yearbook. This was the title page for the schools of engineering. Someone didn't completely understand heavier than air flight. Airplanes going down, and somebody decided what you need to do is to dump ballast, which of course isn't the way you go back up in heavy aircraft. But this probably wasn't surprising because this was before there was even an airplane in Tippecanoe County. First airplane in Tippecanoe County didn't show up until 1911. Well, anyway, Gus here, Professor Gusson and Professor Cardino, and I did put together a history of the aero school. We called it One Small Step, the History of Aerospace Engineering at Purdue. 2 editions. The first one was 1995, which was the 50th anniversary of the department, and then the last one was when we updated it a few years ago. So this is a pretty extensive history of the department. We've documented all the graduates, all the faculty, all the theses. All the degrees, I added up, we've, I guess, produced over 10,000 degrees since we've been a separate school. real quickly, change thing here. I do want to say something about some reflections here. I've had a wonderful experience with Australia, and I do want to comment on that. I've had a bunch of I've had 15, I think, Australian Air Force students that have done theses with me, and then I got the opportunity to go to Australia and about a dozen times and teach short courses there. These guys, I'm pretty proud of. As I said, I've done short courses for a long time. Back in shortly after I came to Purdue, I was doing a short course with Air Force people in George Washington University, and we were talking about fractional mechanics, and we were talking about how the Air Force changed their design methodology to crack growth based. One of the people at that class was a guy from the embassy, Australian embassy. He was an Australian Air Force officer, and he approached me later, and he said, you know, the U.S. Air Force is changing the way they manage planes based on crack growth mechanics. He says, we've got to get that technology into our services. And so he said, I'd like to set up a program where we send a highly select officers to Purdue, get a master's degree, and then they would return home. So we did that, starting in, the first one was Adrian Morrison, starting in 85, I guess. And then every 2 years after that, we had a guy come. These were wonderful, wonderful guys, highly selected guys. If you know, for our master's degree, we have a thesis option and a non-thesis option. For non-thesis option, you take 10 courses. For a thesis option, you take 7 courses and do a thesis. These guys did both. These guys took 10 courses plus the thesis, and they did it all in 3 semesters. So these were very good students, very good guys, and it was a great pleasure to work with them. You know, 2 of them eventually became generals, air commodores, I guess they call it, in the Australian Air Force, and we recognized them. Again, to toot my horn, one of the last times I was in Australia, I did go to where these guys work, and their general gave me a nice little letter of appreciation, gave me this nice little plaque, and you know, I guess I am somewhat proud of this. He says he's thanking me for postgraduate training. He says that these graduates have been very valuable structural integrity managers, and then he says something at the end, you know, the education training you provided represents a distinguished and enduring legacy. So I'm pleased for that. So I will toot my horn on that, I guess. One other reflection. One of the hardest things I've had to do is this winding down is winding down my research. You know, I've stopped taking new grad students, and that's been a real difficult thing to do. But I've tried to think of, you know, doing a little philosophy about research. Why do we do research at this place? Okay, and I've got a little bit of a perspective on that from 3 different other organizations. Why do you do in-house research? It's very expensive. When I was working at the Air Force, I was mostly involved in in-house stuff, the same kind of things I did here. But most of the lab's budget was contractual, hiring guys on the outside. We had a new lab director one year. He came in from the branch that didn't do any in-house stuff. They hired everything. And he said, why should I be spending all this money on in-house guys doing research? Why shouldn't I just spend all that money hiring? So we had the chief scientist do a big study about that. And they came up with what I thought was a really good answer to that problem, is you need smart people to influence the contract program. He says, I've got to keep my contract monitors honest. And the only way I can keep them honest is if I have some in-house technology that can tell us what are important areas of fund. Okay, and we're making good progress. So I like that answer. But also, I accepted it, as being an in-house guy, I accepted that it says, hey, I've got to also contribute to the contract stuff. You know, I usually try to avoid the contract stuff, but I said, well, you know, I need to do my fair share of doing contracts. So I started doing a little bit of contract stuff after that. So that was one experience. The next one was I spent 6 months several years ago at Alcoa Technical Center. Beautiful research park on the outskirts of, well, in Monroeville, out in the woods outskirts of Pittsburgh. And again, they do a wide spectrum of research, very basic stuff, very applied stuff. And I was there and realized that the research they were doing, though, had to influence the bottom line of the company. You know, they were in the business of selling aluminum, and so the research, even though it may be basic, it had to influence the bottom line of the company sometime. And that aluminum lithium is an example of that. So I appreciate that. Then about 5 years ago, I spent a year at an undergraduate place, the Air Force Academy. That's all undergraduates. There is some research that goes on there, but not very much, and the people who do research aren't really involved in the teaching. Most of the teaching is done by most of the teaching is done by junior officers, and there's not a whole lot of scholarship there. Okay, and even though these guys are very enthusiastic. I wish our colleagues here were as enthusiastic about undergraduate teaching as those guys were. Some technical stuff wasn't as deep as it could have been. Okay, so why Purdue? Well, with this background, I think the reason we do research at Purdue, first of all, the obvious things here: advanced technology, support students, obtain modern facilities. But I think I like the answer from the materials lab. The reason we do research at Purdue is so that we can attract the best possible faculty. Okay? Good people are going to want to go to places where they do research. So we do that. And of course, research keeps them smart. Okay? And it lets them develop. So having said that, I think there is a real strong obligation for those of us who are involved in the research that we impact the bottom line of the university, which is the students. So I think we do need to impact the teaching efforts of the university. Developing curriculum, teaching students the latest technology, and sharing the excitement. Well, Geezer's final reflections. 45 years, things have changed tremendously in industry. When I went to school, there weren't any calculators. Everything was side rules. No GPS, no word processor. We locked the women up. I didn't. The university locked the women up at 10:30. At 10:30 on the weekends, and I guess it was 1 o'clock or 10:30 in the week and 1 o'clock at night. I remember Bob and I were dating. I'd have to get her back to the dorm by 1 o'clock on the weekend. Of course, everybody would be standing out at the dorm at 1 o'clock, saying their goodbyes until they started flashing the lights and made you go in. That certainly has changed. I guess one of my, when we got married, I was real happy to assume that responsibility of doing the bed check. And I probably moved them up earlier than 1 o'clock too. And also at that time frame, when I was a freshman, ROTC used to be mandatory land grant schools. When I was a freshman, last year was mandatory at Illinois. Had I not had to take it, I'm not sure I would have stayed with it. Purdue actually, I think, continued ROTC up another 5 years or so later than that. Well, at any rate, self-taught most of it. So the deal here is, what do our new students need to know? Things have changed so much in my 45 years. What are kids going to need to know for their next 45-year career? And of course, you all know this. The main thing is to teach students how to learn. Okay? The stuff we teach them is going to be obsolete in 5 or 10 years, so they're going to have to continue to be able to learn on their own in informal settings. So we've got to prepare them for their post-Purdue education, even though that in many cases that'll be an informal basis. Okay, well, in closing here, I've been had a wonderful career, 45 careers. Purdue's been a wonderful place. Had the opportunity to contribute to safety, improving the safety of airplanes, this damage tolerance stuff. Being a professional warlord, I'm content. The school has been wonderful. Again, I'm exactly the same age as the school. And if we want to think about life extensions, I'm not necessarily thinking about my life extension, but think about the life extension of the department. You remember there were two things I said we had to have. We had to have a sound design, and I think the 70 years that we've been as a department, 69 years we've been a separate department, we have a wonderful design, wonderful curriculum, but we have to maintain it to keep it up. So to extend our career through our school through the indefinite future, we need to do that. Okay, get the Medora Prize. I haven't said anything about the space program. Again, one of the neat things about being in this place is you see astronauts all the time. Heck, I've had the opportunity to meet 5 of the 12 guys that walked on the moon. That's kind of a cool thing to be able to say. This is a picture I took of the dedication, and when all the astronauts were here, the dedication of this building. I want to mention Charlie Walker. If you remember, on his first space shuttle flight, he took gum seeds up into space. And then he started planting trees from them. And over in Grissom Hall, we had a tree that was grown from one of the seeds which Charlie took into space. Well, I've been interested, I guess, because my dad being an agronomist and so on, I've been interested in seeing if things would grow. So I've been collecting seeds off that tree in Grissom Hall, these little pods. You let them dry, and you get all these little seeds. And so for a number of years, I've been collecting those seeds and then growing little trees from them. Actually, here's one of the biggest ones I have. This was at home. This is actually pictures a couple years old. This tree is quite a bit bigger now. And one of these days, I think there's going to be grandkids. But good to have this year. So anyway, my door prize is a bit of history, or not history, a bit of the space program, a bit of history with Grissom Hall, and a bit of history with Charlie Walker, is I brought a tree. This tree's mommy was an astronaut. Okay, and so that'll be my door prize. And the way I thought, if there's more than one person who wants it, I thought the way we would decide is the person whose birthday is closest to the July 1st, the anniversary of the department. So thank you very much for the opportunity to talk to you, and good luck.
Skip will be happy to answer some questions.
Yeah. Thank you. Let's see. Tom?
Well, maybe I can ask you to give a talk, even though you're already on your phase retirement, because we have all learned so much from Skip. Well, a few things I just want to let you know. For example, I know that you went he's one of the best teachers we've got. And so I can see from today's lecture that's very entertaining and everything. But the other thing is, Skip, in addition to being, I'm very lucky. I really feel I'm being part of this great university. There are people like Skip and John Collins and stuff. They're the leaders of this school, the main school really is. And I think one of the ways Skip taught, this place is so good. It's so, even though we're about space, but we're so down to earth, right? It's all about doing things, it's about why we do it. Very, very tough by every step. But one of the things I want to mention about Skip is not just humble, but incredibly good, but also incredibly gracious. He used our race bank distinguished professor. And I'm not sure, when you're a distinguished professor, you actually get, I think, $50,000. But Skip gave that voluntarily, so we can retain other people. So it just shows the kind of person that Skip is also. So I always had incredible admiration for Skip, because actually, well, he has taught me a lot, very quietly, but every time when I do something wrong, he tells me very quietly. So I'm very grateful to Skip. So thank you very much.
Well, thank you. Well, I just saw this tree. I think this is probably the first, second generation tree. So maybe I can get a paper out of that, talking about how you go into space, you're not sterile if you go in space. So, well, thank you very much.